Hi everyone, welcome back to AutoCAD Term 2 MEM 30031A, MEM 332A. Just a little bit of disclaimer. This online recording is intended for internal teaching within South Metropolitan TAFE, Carlisle WA campus only. You may not either directly or through the use of any device or other means copy, download, upload, publish the content unless expressly permitted by South Metropolitan TAFE in writing. Now, in term 2, let's see, we are focusing more to HVAC engineering drawing. You have been learning in term 1 how to operate CAD in general. You know how to use the line, how to use a circle, how to use spline, and all sort of things. So those are the foundations for the term 2, which is focusing to HVAC engineering drawings. We did discuss a little bit of some components of to the HVAC in term 1, but in term 2 we'll focus heavily on HVAC drawing. So for today's lesson, I would like to begin with um, very common equipment that we are using in HVAC. So I understand some of you are familiar with HVAC in commercial buildings. Some of you may familiar in HVAC in other form like automotive industry, or you may not have any prior experience to any HVAC system. So this drawing is limited to buildings HVAC in building services only. Okay, let's start by looking the main component of HVAC. One of the main component of HVAC is what we call air handling unit. So this is a typical air handling unit. I will put this Microsoft Word in Dropbox. So if you click the link, you can have a look and probably have a read what is the air handling unit supposed to be. We're not going to be spending time in details of each component, what is the functionality, what is for, because that's outside of this course. However, feel free to research it in your own time, and I will point out some useful website, or you can email me. So the purpose of a handling unit is to move the air. As you can see here, this is at the back of air handling unit, what we call return air plenum, or if we have an outside air intake, we call it mixing plenum. You can see a little um, pipe coming out here. It looks very small to me, so it might be heating water. And then this is cooling coil or cooling, or the in the system will be just a refrigeration evaporator coil. Then you will have a fan chamber here. It comes in many combination. It can be horizontal like that, it can be vertical, it can be horizontal and stack. So there is no limit how the air handling unit looks like. Air handling unit in a building, it might be located in one dedicated plant room, and it deliver air via ductwork. As you can see in Carlisle campus, we went to the plant room the other day. There are a couple of air handling units on the floor, which is delivering air across the building section F. The section the second components we want to discuss, you probably doesn't know this much. We call this VAV box, or V stand for variable, A for air, another V is volume, so variable air volume box. The idea of using VAV box is to vary the air supply into the room that being served by the box. In this case, for example, if you look this representative symbol in AutoCAD is like that. Is say 600 liter per second, means we can vary the air probably around 600 liter per second to 0 liter per second if you like. However, Australian standard 1668.2 doesn't permit to close the air into the occupant area completely. You have to have a certain air into the space, so we can't shut this box completely. But you got the idea. The idea is to vary the air. Now this particular VAV box come from Selmec. They use what they call aerofoil wing. So the shape of the damper does look like airplane wing, hence is high in aerodynamic profile, so resulting in less noise. However, other VAV box is just simply butterfly damper, which is just opening or closing just to redirect the to restrict the air. The next one is what we call fan coil unit. Now, the terminology fan coil unit is very broad. Some people say, well, fan coil unit, how big is fan coil unit and how big is air handling unit? Well, it's a bit a gray area. We're just gonna say air handling unit is more like a bigger box, while the fan coil unit is looks like this, which is everything inside is being compactly made and then is proprietary from the manufacturer, while air handling unit is built on request because you can resize it as as much as you can if you like. I've designed air handling unit before for hospital in Australia. It can be 4 meter long, 5 meter high, um, 3 meter wide, and has probably 10 fans on it. It's possible. So there is no limit on air handling unit, but fan coil units, they are pretty much limited. Similarly, like air handling unit, you can have a chill water or you can have a direct expansion or DX. So for the chill water, the means of cooling or heating is using a water, so water coming in from here and coming out from there, or from heating, heating water coming here, heating water coming out from there. You might see if you zoom in, there's a small pipes and bigger pipes. So the small pipes are heating water and bigger pipes is chill water. This one here is direct expansion, so I use Daikin in this case. However, there are many brand in the market which is kind of having very similar shape. They have clear plastic which is for drain. So if the plastic on the top, they normally use pump. So this unit clearly has a built-in pump to drain out the water coming out from the top and then to the drain point. If the drain from the bottom, that's generally indicate it doesn't have a pump. And the two pipes here are for the refrigerant liquid and gas coming in. The next one is the same, is fan coil unit, but what we call a cassette fan coil unit. This one is ducted type. This is a cassette type. In AutoCAD, we normally just make a rectangular like that, and then we call it FCU. So this cassette unit, if you go to the Seth office and look up the ceiling space, there's a big cassette unit there. It does function similarly with this, except this is a ducted system, so it looks nice and neat. You don't see the unit. It's like in our computer lab. What you only see is a couple of air diffusion, while in here the whole face, if you like, the white things there is visible and you can see. The next one is humidifier. So this is one type of humidifier. There are many types of humidifier. I'm not going to cover it here. This is one of the HumiSteam type from Carroll. Basically, you can see this is the heating element, which is goes into this uh, blue wrap barrel or cylinder, which is heating up the water. So as the water heated, is produced the steam, and the steam is distributed into the ductwork. And the symbol that we normally use in humidifier is just like that, like a sprayer which is inserted inside the duct. The purpose of humidifier is to add the moisture into your airstream. In Perth, the use of humidifier is limited. Generally, they are to operating theater or to museum where you want to maintain um, the temperature and relative humidity at the same time. Other than that, I hardly see the use of humidifier in Perth. Sometimes data center as well. This another humidifier layout, which is you can see here. This is the humidifier, and then there's the duct that distribute the steam, and then you kind of have like a sprayer inside the ductwork where the air goes from here and then bring the steam and carry on to the destination. The next component is chiller. So chiller is very interesting technology because um, for the amount of electricity that you supply into the chiller, you can expect up to 3 or 4 times cooling capacity. For example, if you supply 1 kilowatt of electricity, generally the chiller will be able to produce 3 kilowatt of cooling capacity. Water cooled, um, some water cooled chiller, if it's tuned properly, sometimes we can have a 10 times. So 1 kilowatt of electricity, 10 time cooling capacity. But to calculate the performance or efficiency, we need to calculate everything from the pump in cooling tower in case of water cool, um, fans, air handling unit, and then we got total overall plant capacity. But that's different discussion. The next one is cooling tower. So cooling tower generally used for water cooled chiller because as this chiller reject the heat has to be carried away and reject into the atmosphere. In the air-cooled chiller, the heat rejected into this condenser fins, and then the fans will just reject the air or the hot air directly into the atmosphere. In water-cooled chiller, like in the Carlisle TAFE, what we need to do is actually to run another water into this heat exchanger, and then that water is hot, and then it circulated into this cooling tower and get cool. There are um, many types of cooling tower. You can go to baltimoreaircoil.com to learn about a lot of type of cooling tower and the technology behind it. Next one is ductwork. Now we normally hardly seen ductwork because they're normally hidden in the ceiling space. Um, if you went to the plant room in block F, you can see partial of the ductwork in the plant room, and that's how that looks like. Or in this case here, I have a picture that I pull out from the internet. That's the general messy ductwork on the roof. So you can see here not just a ductwork, we can see here a couple of remote air condenser, not necessarily a chiller. This is looks like to me a package air conditioning unit. This is air handling unit maybe, or just a package air conditioning unit, is not clear. But ductwork In Australia, we have to insulate them unless it doesn't carry heating or cold air, such as like an exhaust. But as the building requirements getting stricter and stricter, um, the National Code of Construction Australia actually say, if in Perth particularly, if you have the exhaust more than 1000 liter per second, you have to somehow recover the energy so you do not let that air out into the atmosphere. But for our point of view, in AutoCAD, generally ductwork is represented by a hatching. So ductwork without insulation will be just like that. Ductwork with external 100 mil external insulation, the hatch will be maybe like a dot dot dot, and then 75 external will be cross, and so far so forth. Some people use different type of hatching. This is just a hatching that we use in our company. This is a typical internally insulated ductwork. So you have a duct skin, which is made from galvanized steel sheet. Then you have an insulation, which is normally a fiber, and you have sisal face to protect the fiber. In this case, it looks like non-perforated sisal. You can have a perforated sisal for better acoustic transfer. Basically, perforated sisal, you have tiny holes in here, so the noise energy can be absorbed into the fiber and distribute and disappear. If you don't have perforated face just like that, the noise is getting a bit harder to be absorbed by the fiber. The external insulation for those who come from Asian country, humid tropical country like me, I'm come from Indonesia. Normally all the ductwork are externally insulated like that. The reason being is internally insulated. If you don't insulate it properly, there is a chance that the moisture may condense and soak this fiber, and the insulation become useless. By wrapping it outside is easy, and then if you want to do maintenance, you just cut it and replace it again. But external insulation doesn't absorb any noise, so any noise that coming out from your central plant, say from your air handling unit fan, will just be carry on, carry on, carry on, carry on, because there is no fiber to absorb the noise energy. The next important things in air conditioning system is air filters. So this one particularly, this is a HEPA filter. It's used a lot in the operating theater or in clean room facility. In general air conditioning, we normally have this type of multi-pocket filter, or we can have a air pleat disposable filter, or we can have a free-form type. The black one is a carbon filter if you have a kitchen exhaust in the commercial slash residential building. Normally you want to filter the kitchen exhaust with the carbon so it doesn't affect the residential people that's sitting out in the balcony and smell a bit of cooking. Air filter is also important because it protect your coil, it is prolong the cleaning of your coils and keep the coils healthy. Otherwise, once the cooling coil or heating coil are clogged, your performance decrease, and of course you have a lot of dust into the system. Pipework, if you design a hydronic system, we normally have a chill water and heating water pipework. This is how it looks like in the real life. So you can see here part of the pipe has been cladded with aluminum cladding. Some of the pipe hasn't been cladded. You can see this is a silver lining. This is what we call a styrene insulation with a vapor barrier. So this aluminum foil is actually a vapor barrier. For extra protection, normally they clad this again with aluminum, so somebody, if someone work on it, it doesn't damage the insulation. In AutoCAD, it's generally just a dash line, or you can draw the real size of the pipe. This is very colorful, pretty handy to paint the pipe, so you can trace it. Generally green is a cool or chill water. Red looks like either the fire or heating. Yellow is looks like a condenser water, and you can paint in any color you like. This one is pretty straightforward. It's two pipes. Uh, it might be chill or it might be heating, but the point is metally cladded for outdoor, so the sun doesn't damage the vapor barrier. Pumps, there are many type of pumps. This type of pump is what we call inline verticals or inline centrifugal vertical mounted pump. There, there are other types of pumps, so you can Google it. In AutoCAD, we just have a circle and triangle. So it's pointing this way means flow is going that way. Fans is another typical equipment in air conditioning. There are many type of fans. Go to fantech.com.au. We have a axial fan, roof mounted. We can have an inline centrifugal fan as well. Fire damper is very important. If you have a fire wall, this is the barrier between those two if you're penetrating that firewall. In AutoCAD, we normally just have this rectangular with a like triangular yellow or white, whatever the color, and then we put FD as a fire damper. So the fire damper in this case is curtain type. We can have a opposite plate fire damper too. The idea is once the hot air passing through the fire damper, this link is what we call fusible link. So the link will melt under certain temperature, and the curtain will drop, so maintaining the fire barrier. MSSB or mechanical services switchboard. This is where we normally power all the mechanical equipment. I'm not too sure in other country. I know in Indonesia for sure they separate mechanical equipment power supply from the general electrical distribution board, and that's generally a good practice. We don't want to mix the mechanical equipment to the general distribution, just in case somebody mistaken the chiller supply with um, other supply and then they accidentally shut it down. In certain area, sometimes the chiller can be directly supplied from distribution board because the chiller has a lot of um, amperage or high voltage, and there's no point to um, run the high voltage cable into another board and then supply the chiller, which is you losing the voltage. But generally in Australia we try to have a dedicated mechanical board for all the mechanical equipment. And one is finished, it looks like neat like this, and this is probably mixed between power supply, and probably in the middle looks like a control board, so all the automatic control are stored in here. Next is air diffusion. If you remember where we sit in the computer lab, we have 4 air diffusion looks like that, spread over the classroom. So this is what we call four-way curve. Um, we can have linear diffuser. We can have double blade register. We can have multi-blades. We can have perforated blade. We can have a circular or jet diffuser. So air diffusion, generally we show it like that. So in this case it's swirl. This one is probably multi-blade like that, but it's only two, not four. Cushion head. Commercial building generally will have a cushion head on top of this air diffusion. So the reason is the air coming from this spigot here and then go into this little plenum, and the air is distribute mix evenly here and then distribute into the diffuser. In house, generally we don't have a cushion head. In house, what we have is we just have a neck or a circular connection behind the diffuser, and then we connect the flexible ductwork directly into the air diffusion. Flexible connection, this generally to separate the vibrating equipment from the static equipment. For example, on this side we may have a handling unit which is vibrating due to the fan, and on the other side we have a ductwork which is generally static. We use flexible connection so the vibration from a handling unit doesn't get transferred into the ductwork and causing an issue downstream. Flexible ductwork, this is what the symbol in AutoCAD. Flexible ductwork generally used to do the final connection between the solid ductwork into the cushion head or directly into the air diffusion. Variable speed drive, we use variable speed drive now, and it's pretty much very common. The price is not too expensive, the technology is very advanced. By using variable speed drive, we just basically control the speed of the equipment as per demand. So if you imagine if the room is fully occupied, we turn the fan at 100%. When the room is only halfly occupied, we can slow the fan to 70%. And if the room is not occupied, just to maintain the freshness, the air change rate into the room, we can run the fan at 30%, hence saving energy. In the old days, we always run the fan at 100% and consuming 100% of energy all the time. Dampers. Damper is used a lot in HVAC industry. They can be used for smoke control. They can be used for balancing. They can be used for shut-off damper to shut the air. So in this case, we have a damper, which is multi-blade damper, like that, and this is an actuator to control it to open, close, or to modulate. In AutoCAD, if motorized, we stick M on it, M for motor, and this is typically a symbol representative for the damper, which is just a linkage damper. Building management system. In commercial building, we normally automate our building process. We let the computer to control when to open the damper, when to start the plant, when to turn off, what temperature, what's the temperature gonna be, um, turn the light on off, turn the water pump on off, and a lot of things, and monitor the health of the building. So we use a BMS quite a lot. You will see this very common in the commercial building. So BMS generally is just this controller which has a built-in computer into it, and then you can program whatever you like. If you have a chill water heating water system similar to the damper for the air, we have a valve for the water. So remember we discussing damper before. So the purpose of damper is to control the flow of the air or restrict the flow of the air. In water or hydronic, we use valve. In this case, we have what we call pressure independent valve, which is self-control. So this is the actuator, and that is the monitoring as well. So the water coming through here, say you want the valve is selected from 1 to 3 liter per second, and the valve will ensure 1 to 3 liter per second through this valve is maintained regardless what kind of pressure. In AutoCAD, we normally use this, so MV motorized V valve. And you have a little bit of square on top to show the actuator. The next one is temperature sensor. So the temperature sensor is normally in the room, sometimes in the written air ductwork. If you go to our computer lab, they are on the wall, hidden behind the metal perforated plate. There's a temperature sensor, so the air sample goes into this grill and gets sensed, and this will give feedback to the HVAC unit whether you are too cold or too hot, and the system has to adjust accordingly. Temperature sensor is TS, just like that. Back again to hydronic system. On top of the motorized valve to control the flow of water, we normally also have balancing valve. The reason we have balancing valve is, as the name implies, is to balance the water. Sometimes the motorized valve alone is not enough, as the system is dynamic. If you have 100 of fan coil unit opening and closing simultaneously, you may have imbalance system in your water pressure, and you need to balance the system, so use this balancing valve. And normally the symbol is just like that to to represent this sample point within cold and front and the back, so incoming and outcoming of the water, although it's red and blue. Check valve, again in hydronic system, check valve is used as a one-way valve, so the water coming from here, from the back, and to here. Can you see the spring here? So as the water coming from the back, it push this plate open. As soon as the water doesn't have enough pressure or the pump is off for some reason, it will spring close and then shut the system. So check valve or one-way valve is very handy if you have a multiple pump installation. So you have a one check valve per pump just to make sure the water doesn't go round and round and round in circle. Next one is a strainer. So the purpose of the strainer is to trap any dirt in the water. So the water coming from this side is pushed into this side. This is a strainer here, so it's like a mesh. So you open the bolt and clean the mess every now and then put it back in. So it's very robust system, but you have to clean it very often. McNeil gauge is basically just to show what's the pressure differential between one location to the other location. We normally stick this between the air filters, so in one at the back of this McNeil gauge there are two ports. One is incoming, one is outcoming. So incoming you stick it behind before the air coming to the filter, and the other one after the filter. So you can measure what's the filter pressure drop, and once the filter pressure drop reach certain pressure, indicate that the filter is dirty and need to be replaced. This is the manual McNeil gauge. We can have the BMS McNeil gauge as well, what we call DP transducer. and that will give feedback directly to BMS and send an alarm. Relief valve. So relief valve is normally used in chill water system or heating water system to um, release the air from the system. Sometimes it can be used also in steam, just to make sure if the steam pressure in the system is too high, we're just gonna relieve it. This particular is an air vent, but the symbol is generally very generic. So safety valve, or we can change it to relief valve, relief valve, or we can change it to AV, which is air vent. Last component, air compressor. So air compressor is actually part of the HVAC services. There are many type of air compressor, but this particular is what we normally see in our life. Sometimes it's just little box, sometimes it's humongous and bigger than this. If you would like to learn more of the air conditioning system components, you can go to ERA. Let me see if I can pull it out here and buy this book, Assurance Refrigeration and Air Conditioning Volume 1 and Volume 2. This is by Graham Boyle. Graham Boyle is actually the staff member in our campus, so you have to be proud. You can also borrow this book from the library, but it wouldn't be this latest revision, but I think it's a good enough. But if you would like to collect, you can click here and purchase it. It's very handy. The next one I would like to discuss is uh, assignment 2, which is I'm going to probably put it on the separate recording. So this term 2 will have a test on 9 of June 2020, and I need everything submitted for assignment 2 on the 23rd of June. The next one I would like to point out is ERA Technical Handbook here. If you're a student, you are free to join ERA, which is Australian Institute of Refrigeration, Air Conditioning and Heating. So this is an Australian body or organization, if you like, that normally looking after all the heating and ventilation and refrigeration in Australia. They're normally very involved in developing the new standard or guidelines to help with the air conditioning industry. If you are a student, I'm pretty sure you can access this handbook online and you just view it on your web browser. But in this handbook, there are many sections, which is very handy. Bear in mind, my handbook is 2004. I bought it when I was a student in 2005 when I was at TAFE, and I'm still using it now in my work space. I haven't actually used 2013. It's not 2013 has a nice other revision, but my 2004 is pretty good enough. But in here you can have a lot of um, data, general information about HVAC, which is very handy. Got PAM laws, thermodynamic laws, typical design data for air conditioning system, velocity where you need to run your ductwork, although some of them I kind of disagree. Temperature, um, chill water system, and then if you scroll down here, we can have ductwork sizing chart, and we can have ductwork pressure loss. So for this kind of fittings, you can calculate what is the K factor or the fitting coefficient of this, and then you can calculate the loss. You can predict what is the loss through the fitting. So this is a pretty neat and very handy. If you need to draw ductwork in AutoCAD, you can refer into this handbook as well. The next one I would like to point out is Australian Standard. So 4254.2 is for rigid duct, and 4254.1 is for flexible duct. We tend not to use flexible duct so much, but let's scroll down, because flexible duct is generally pre-made. So you can buy it in 3 meter length or 6 meter length, and then you just need to specify what kind of insulation thickness that you like. But the standard does talk how you connect the flexible duct into air terminal device, which is cushion head, and then how you tape it properly and make sure you maintain the vapor barrier and things like that, and then how you hang it. Okay, 4254.2, this is what we normally use if you are doing shop drawing for AutoCAD. You use this. This is the reinforcement, which is normally been taken care by the duct manufacturer. They will do this, so you will just gonna skip this into probably about this section here. So this section talk how what is the distance of duct reinforce. So when you drafting it, sometimes you want to mention the duct is hang every meter or every 600 mil whatsoever, and then this is typical uh, drawing of the duct. So you need to note 45 shoe fitting. You want to damper here. What is the angle from here? What is the size of the ductwork, whether it's metal size or insulation size? Do you want fire damper? Do you want an access panel? Cross means you looking at the cross section of the supply air or the duct. This is a typical how you draw it. For the purpose of shop drawing, really, you can draw the duct any shape you like. I do have one project that the duct is probably looks like a triangle duct, which is very uncommon. It can be done. The reason of that because the ceiling space is very limited, so the duct has to be similar shape of the roof truss. But the key idea, if you're doing a shop drawing in the ductwork, is to minimize the waste. When you minimize the waste, then the price of the ductwork it become less, and then of course it's very good for environment as well. So keep browsing on this Australian standard. You actually can access this Australian standard via South Metropolitan TAFE library. If you're not sure how you access the Australian standard, just ask the librarian downstairs and ask them to search AS4254 for you, and you can download it, but it will expire for certain days and you can't access it. But please do not print, as this is copyright. Last but not least, before we close today lecture, is this back to basics duct design presentation. So this is from ERA as well. If you search it in Google, it has been archived. So Christopher put together quite nice presentation, how you test the duct leakage and what is the manufacturing duct of the ductwork looks like. And what the software that the duck manufacturer normally use. So do have a look this presentation, and that's it for today. I will upload um, some of this material into the Dropbox. I wouldn't upload the Australian standard. I wouldn't upload the technical handbook because they are copyright, but you can Google it. Thanks guys. Hope you enjoyed this lesson and see you next week.